Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, let's have a look at this change the base one. So again, solve for log to the base x of 2 minus log to the base 2 of x minus 3 equals 0, okay? So why do I call it a change the base? Well, when I'm looking at the base numbers, can you see that they're different, okay? Excuse me, and for as long as they are different, we can't really use the rules of logs, okay? So what you have to do is you have to change the base number of one of them so that they match. Okay, does it matter which one you change the base of? No, not at all. Okay, so I'm going to take this one first, and I'm going to do it both ways. I have the sum written here again. I'm going to do it both ways so that you see that it makes no difference. So I want to change him. So change to base 2. So I'm changing that to be a log to the base 2. Okay, so I'm using this rule over here. So I write down the one I need to change. So I need to change log to the base x of 2. Okay, so to map that to the letters, my b is my x. This x here for me is 2. And a up here is my new base. Okay, so he becomes, and I'm just subbing into this formula here, okay? So he becomes log to the base a of x. I'm just following these. There's my 2 and my 2 over log of a 2 of x. Log to the base 2 of 2, when the base number and what you're getting of the log of matches, you get 1. So it's over log to the base 2 of x. Okay, so I'm going to sub that back into this equation so that I have 4. So now watch, I write this with base 2. That's what I wanted to do. So 4 times 1 over log to the base 2 of x minus log to the base 2 of x minus 3 equals 0. Okay, hard to solve this as is because there's no rule if you check the log tables for 1 over log of something. Okay, so the easiest way to do it is to let y stand in for log to the base 2 of x. Okay, so then rewrite this one as 4 by 1 over y minus 3 equals 0. Okay, there's a fraction here, so the easiest thing to do is to multiply across by y. Okay, just get rid of that multiplied sign in case you get confused. So multiply across by y. So multiply by y, by y, by y, by y. Okay, and that y cancels. So this just becomes 4 ones are 4 minus y squared minus 3y equals 0. And I'm just going to write that with positive numbers then in the order ax squared plus bx plus c equals 0. So what I did from here to here was change the order and change the sign. Okay, so let's solve him. Y and y, factors of 4, that gives me 3, are 4 and 1. It's a minus 4, so I'm going to have plus and a minus equals to 0. Okay, so I'm getting y equals minus 4, y is equal to plus 1. Okay, now normally when I'm dealing with logs, I get a little bit nervous of minus numbers, okay, but they're okay when the y's are minus numbers. It's when you're getting the log of a negative number that it doesn't make sense, okay. Am I finished here? No, because when you were asked to solve this equation, you were told to solve it for x. X was the variable that was in your sum, okay? We introduced y here as a temporary measure to help us solve this log question, okay? So now we must, I suppose, remove y from our equation and solve for x, okay? But y was equal to log to the base 2 of x, okay? So therefore, we can now say that log to the base 2 is equal to minus 4, which was our y, and log to the base 2 of x is also equal to 1, which was our other y. So log to the base 2 of x is equal to minus 4, and log to the base 2 of x is equal to 1. Okay, so I'm going to use this rule like I normally do to cancel the log and be left with just the x. I match the base and raise everything to that base. My base is 2, so if I raise everything to the base 2, so what I do to one side, I have to do to the other. What you'll find is log to the base 2 and 2 cancels, and you're left with just x being equal to 2 to the minus 4, which you can put into the calculator, and it's 1 over 2 to the power of 4, or it's 1 over 16. You do the same to this side. I'm going to raise everything to the base 2 again. I got that base number from here, so I'm matching my bases to it. And what I do to one side, I do to the other. So x is equal to 2 to the power of 1 here, x is equal to 2. Okay, so that's when you change log to the base x to a base 2. And it's probably the easier way to go, but I want to show you that you can also change this one to base x. Okay, I can do that one. I can make this one match this one. Okay, so just like before, I'm changing log to the base 2 of x. Let's get the rule. Let's map. Okay, my b is my base number and x is x. Okay, so b is my base number and little x is equal to x, and a is my new base number. It's what I want to change it to. Okay, so let's change it here. I've log to the base a of x, so log to the base x of x is what I have with my figures. Over on the bottom, log to the base a of b, so log to the base a of b. Log to the base x of x is 1 over log to the base x of 2. Okay, so let's sub it in. I have 4 log to the base x of 2 minus 1 over log to the base x of 2 minus 3 equals 0. Let's use y to be log to the base x of 2. So I'm left with 4y minus 1 over y minus 3 is 0. I'm going to multiply across by y. So I get rid of that fraction. So I have 4y squared minus 1 minus 3y is equal to 0. Let's write it in the correct order of a quadratic. So 4y squared minus 3y minus 1 is equal to 0. Let's solve it. So I have 4y and y, the factors of 1, and I need minus 3y, so the minus goes there and the plus goes there. So 4y is equal to minus 1, y is equal to minus a quarter, and in this one, y is equal to 1. Okay, so sub back into y is equal to log to the base x of 2. Okay, and what do we get? Okay, well, I get log to the base x of 2 is equal to minus a quarter, and I get log to the base x of 2 being equal to 1. So just like before, I'm going to raise everything to the base number. So x log x2 is equal to log minus a quarter. So I get 2 being equal to x to the power of minus a quarter. Okay, remember what I want to do with him. This is the tricky one now. I need him to be x to the power of 1, because that's what x is. You solve for x, that's x to the power of 1. So what must I multiply that power by to make him 1? Well, I must multiply him by a minus 4. Okay, and if I'm multiplying that side by minus 4 in the power, I have to do the same to the left. So I get 2 to the minus 4 is equal to x to the power of 1. okay? And 2 to the minus 4, just like we had here, is going to give me that x being equal to 1 over 16. Okay, now let's do the same to this side and solve this one. So everything gets raised up by x. Log x and x cancels. 2 is equal to x to the power of 1, or x is equal to 2. Okay, so it's a tad easier when you change base x to be a number, I suppose, or that's definitely the pattern that we're seeing.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.